Hi guys, this is Mrs. Allison, and I'm here to finish the second part of these notes, the radians part of the angles and radians notes. So you should flip over to the back side of your notes, and let's talk a little bit about what a radian is. I noticed in typing this up that my definition on the note sheet looks like it's missing a few words, but it says a radian is a unit of angle equal to an angle at the center of the circle, which, think back to geometry, means central angle, whose arc length, remember the portion around a circle, is equal to 1 radius. Okay, and I have this visual demonstration that I'm going to play one time to start, and then I'm going to explain it. I want you just to watch it, and then I'll explain it. Okay, so let's watch this again, and let me go through an explanation with you as it goes. Okay, so we take a radius, any length, and we're going to draw a circle. So we're going to call that radius r. And then what we're going to do is we're going to take the very length of r and wrap it around the circle. This angle right here, this arc length and this angle is equivalent to 1 radian. What you'll notice is if I rotate that around the circle, 3 radians and just a little bit makes pi. 3.14159 radians around the circle makes pi. So there's pi radians around a circle and 2 pi radians around an entire circle. Okay, so I'm going to watch it one more time and we'll just look through it again. And sorry about the video quality. We tried to pull the video into this presentation and it wasn't wanting to work. So it's really pretty ghetto on how we did it, but there you go. Watch it one more time. So 1 radius that makes a circle. If we take that exact radius and draw it on the outside of the circle, and I figure out the exact amount of times it goes around the circle, it goes around 1, 2, here it comes, 3, with just a little bit more. That little bit more happens to be 0.14159. So pi, 3.14159. And then the whole way around, if this is pi, is 2 pi. Okay, so let's move on and use that going forward. Okay, so I have the directions here. It says the definition here. It says 1 radian is a unit of an angle equal to an angle at the center of the circle, the central angle, whose arc length is equal to 1 radius. So this dimension right here is equal to 1 radian. I'm going to actually write that in red. So this is equal to, or green, 1 radian. So this is, okay. D didn't come out very good. 1 radian is this angle right here. Okay. So let's think about what this means. What does this mean? Half of a circle is equivalent to, we said, pi radians. And we know half of a circle is equal to 180 degrees. Okay, so there's a conversion factor here. What we're going to be doing with trig is we're going to be using what we know about a circle from geometry, that it's 360 degrees, half a circle is 180 degrees, and we're going to be able to translate that into radians. Okay, so to convert the degrees into radians, looking at our conversion factors down here, to convert degrees into radians, what I'm going to do is I'm going to multiply by a factor of pi over 180. Well, what is pi over 180? Well, pi over 180 is really just 1 because pi is half of a circle and 180 is half of a circle. Okay, so my conversion is pi over 180. So if I convert my radians into degree, oh my goodness, try that again. If I convert my radians into degrees, I'm going to be multiplying by 180 over pi. Okay, so let's look at what that looks like. I'm going to try one, and then you're going to try a couple and see how you do. Okay, so if I want to convert 120 degrees into radians, I'm going to take 120 and I'm going to multiply it by pi over 180. Now think back to Algebra 1, maybe even before when you first started learning fractions in like 5th grade multiplying fractions. We can cross cancel this. I know that I can put this as a factor of over 1, and I know that I can reduce each of these terms by a factor of 60. 60 goes into 120, 60 goes into 180, 60 goes into 122 times, and it goes into 183 times. So my final answer is 2 pi over 3. So the radians that are equivalent to 120 is 2 pi over 3. Okay, pause the video and see if you can get the radians for the other 2 degrees that I've given you, the 30, negative 30, and the positive 210. Okay, hopefully you had a chance to get those. So let's look at what that looks like. Let's see if I can write a little bit smaller. If I go here and I do negative 130 times pi over 180, and I reduce, okay, negative 30 times pi over 180, I get that 30 goes into 186 times, so I get negative pi over 6. So the radian measure, negative pi over 6, is equivalent to negative 30 degrees. Okay, how'd you do? Okay, let's look at 210. 210 times pi over 180, and I can reduce each of those by a factor of 30, looks like. 30 goes into 210 7 times, 30 goes into 180 6 times, so I would get 7 pi over 6. How'd you do? Okay, let's look at that in reverse. Let's convert the radians into degrees. So here, I'm going to multiply by, I'm going to take pi over 3, and I'm going to multiply by 180 over pi. Well, what happens is my pi's are going to go away, and I'm going to be doing 180 divided by 3, which we know to be 60. So 60 degrees is equivalent to pi over 3. Okay, pause the video. See if you can do the 7 pi over 6 and the negative pi over 2. Okay, let's check your work. Let's see how you did. If I take 7 pi over 6 and multiply by 180 over pi, my pi's go away. 6 goes into 180 30 times. So I have 7 times 30 or 210. Well, that should make sense because we literally just did this problem in reverse. We did 210 and found it was 7 pi over 6. So it should make sense that 7 pi over 6, when I convert it, becomes 210 degrees. All right, let's look at negative pi over 2. If we multiply that by 180 over pi. Oh my goodness. Oh my goodness. Not better. Okay, let's try that one again. 180 over pi. And my pi's go away. And then I know 2 goes into 180 90 times, so this would be negative 90 degrees. How'd you do? Great. Okay, if you need to rewind that video, obviously, or rewind that part, watch it again. But let's move on and look at radians a little bit more. Okay, I think one of the things that would be helpful for you is a visualization of what these angles actually look like on a circle. I think mental pictures help us to see where radians might fall. So let's talk about that. Okay, 2 pi. Well, as seen in the video, 2 pi would be the entire circle. So I'm just going to draw that on there. Pi, we saw, was half of the circle. Oops. Okay, now pi over 2. We just saw in the last conversion that we did, if you look back up, that negative pi over 2 was 90 degrees. So that would stand to mean that positive pi over 2 would be 90 degrees. So if we have an angle in standard position, the part of the circle that would represent pi over 2 would be like a quarter of the circle. Okay, so then let's think about how pi over 2 and pi over 4 are related. Well, if pi over 2 is a quarter of a circle, then pi over 4, which is half of that, would be half of a quarter of a circle or an eighth of a circle. And if pi over 2 is equivalent to 90 degrees, what do you suppose pi over 4 is equivalent to? All right, half of that, 45 degrees. Okay, and from before we saw pi over 3 on our video, or our problems before, that pi over 3 is roughly 60. So it's not quite 90. So it's about there. Maybe 2/3 of the way, it's 2/3 of the way up to 90. And then pi over 6, we actually saw when we did the angles, we did -30 and converted it, got negative pi over 6. So positive pi over 6 would be positive 30. So it's just a little bit of the angle here. This is just a little bit of a foreshadowing of what we're going to do next in our next video, which is talking about the unit circle. Now, here's the thing we can do, is that we can use radians in problems just like we did degrees. So remember in the last video we talked about coterminal angles. They share the same starting and ending point. Well, we can do that with radians as well. So let's look at that. If I have a coterminal that's pi over 3, so if I have an angle that's pi over 3, we just talked about that pi over 3 is like 2/3, like 60 degrees. So I would say that angle would be somewhere right in here, right? So this would be my pi over 3. And remember that a coterminal angle has to go around a different amount but have the same starting and ending point. And so if I wanted a positive coterminal angle, I would have to go to pi over 3 and then around and then back to it. Okay, well, how big is a full circle? Well, a full circle is 2 pi plus the pi over 3 would be coterminal. Well, 2 pi, if I want to change it so I can add it to pi over 3, is like saying 6 pi over 3. Do you agree? Plus pi over 3 tells me that my positive coterminal angle would be 7 pi over 3. Okay, what about a negative coterminal angle? Well, if I look at a negative coterminal angle with this, the negative coterminal angle needs to start in the same place but go in the negative direction. Okay, so that negative coterminal angle needs to make up the difference of a whole circle. Well, if a whole circle is 2 pi, and I'm not using pi over 3, so a whole circle is 6 pi over 3, and I'm not using pi over 3, in this case, I would subtract from 6 pi, or I would take 6 pi over 3, I should do it the other way, minus pi over 3, and my angle would be 5 pi over 3, but it's going to be negative 5 pi over 3 because I'm going in the negative direction. So my two coterminal angles would be 7 pi over 3 and negative 5 pi over 3. How does that sound? So we're dealing in terms of 2 pi. Instead of a circle being 360, we're dealing with it being 2 pi. Hit pause, try the next one. Okay. So let's draw this. We know that negative pi over 2, we did that before. Pi over 2 is 90, so this is this angle here. So if I want a positive coterminal angle in the positive direction, I'm going this way. So how much is that? Well, I know this is already negative pi over 2, so the difference between 2 pi, which would be 4 pi over 2, gives me this angle. So I would have 3 pi over 2 for my positive coterminal angle. But then my negative coterminal angle, I'm going to have to go around the circle once and a little bit. Going around the circle once is 4 pi over 2, which is 2 pi. And a little bit would be adding that extra pi over 2. So my negative coterminal angle would be negative 5 pi over 2. How'd you do? Okay, well, this also works for reference angles. And remember, reference angle, if you look back at the front side of your notes, a reference angle is the closest distance from the terminal side to the x-axis. And remember, it's always between 0 and 90. Well, so for us, between 0 and 90 means that it needs to be between 0 and pi over 2, because 90 is equivalent to pi over 2. We saw that up above, and we saw that in our conversions. Okay. So let's think about where 7 pi over 6 is. Okay, if from the initial side to the terminal side is 7 pi over 6. But initial side to this axis is pi, which is the same as 6 pi over 6. Do you agree that if this would be 6 pi over 6 right here? If we were to draw an angle like this, that's pi. That's what we set up here. So that would be 6 pi over 6. So 7 pi over 6 is just going to be below the x-axis right here. So I know 7 pi over 6 is this angle. Okay, now if I want the reference angle, remember the reference angle is the closest angle to the x-axis. That would be that angle right there. And how big is it? Well, it goes from 7 pi over 6 to 6 pi over 6, so the reference angle here would be pi over 6. Okay, hit pause. Try the last one and see how you do. Okay, so let's think about this. Negative pi over 3. We said pi over 3 up here was like 2/3 of the way to the quarter mark. That's real descriptive, but towards my quadrants, it's like 2/3. It's 60 degrees. So negative pi over 3 is going to be like negative 60 degrees. So I'm going to put that down here. So that would be this angle right here. Okay. And if I want my reference angle, it's the closest angle to the closest x-axis, which is the same actual angle. But remember, it can only be between 0 and pi over 2. So my reference angle is pi over 3. Okay. I'm not expecting perfection on the radians yet. I do want you to be able to convert between the two of degrees and radians and degrees. We will get better at using radians because that's the new part of our content. We're taking what we knew in geometry and we're just changing it just a little bit to add a little bit more information to it. So as always, feel free to pause, rewind, stop, rewatch this video as much as you need to. And your assignment is listed in Google Classroom or on that remote learning sheet. So have a great day. We'll see you soon.